Okay, dear students, today we will be discussing about one of the popular multivariate technique, and the topic is canonical correlation analysis, right? So I think you have already some idea. You have already some idea what is canonical correlation, right? So what is canonical correlation? Uh, the most flexible of the multivariate techniques, right? This is one of the most flexible multivariate techniques. So canonical correlation simultaneously correlates several independent variables and several dependent variables. So this is the important thing or important concept in multivariate analysis. When you are gonna analyze simultaneously independent variables and several dependent variables, right? Then this is the concept of multivariate analysis, and this is the mainly the differences between univariate and bivariate analysis, right? So normally in the real life we have several variables including independent and dependent in nature, right? So if we want to simultaneously correlate or analyze several independent and dependent variables, we can take help. And if our objective is mainly the correlation, then we can take help from one of the techniques called canonical correlation analysis, right? This is definitely a powerful technique which utilize metric independent variables. So the independent variables must be metric, and this is not like the MANOVA. Okay, you can consider some of the examples are here. Suppose the sales figure, your satisfaction level, right, and the usage levels. So a lot of examples you can say it, and the real life you can find a lot of examples that you can solve for the canonical correlation analysis. And the data must be related with the multivariate nature, right? So it can also utilize non-metric categorical variables, right? Because this is a correlation, so you can simultaneously analyze several variables together, right? And this technique has the fewest restriction of any of the multivariate techniques. So the results should be interpreted with caution due to the relaxed assumptions. As I mentioned in my first slide, this is one of the flexible multivariate techniques. But as a statistician, if you want to have a good analysis, or if you are looking for an effective output of your data, right? What you have to look, you should have a careful look about the interpretation, right? Because the assumption mostly you can see in the canonical correlation is more relaxed. So your interpretation must be very important when you are going to interpret the findings of canonical correlation. Often the independent variables are related, right? And the independent variables are related also. So finding the relationship is really difficult without a technique like canonical correlation. So what in the real life, we used to observe such a relationship, like the relationship might be between the independent variables and also between the dependent variables. So if you want to find a relationship in that case, canonical correlation is very useful. So canonical correlation analysis is a method for exploring the relationship between two multivariate set of variables, right? So you can say these are the two vectors, all measured on the same individuals. You have to keep in your mind that all the measures. So we are talking about the multivariate variables or the multivariate vectors or the multivariate sets, right? But you have to keep in mind that these variables or these multivariate sets must come from the same individual. So this is one of the most critical assumption of the multivariate analysis, right? So consider an example, variables related to exercise and health, right? So you can consider two variables are here, exercise and health. So you can just simply apply the correlation analysis to see the effect, just the causal relationship, right? Is there any relationship exist between exercise and health? So you can take help from correlation analysis, but I'm not sure about the canonical correlation because we were talking about the multivariate set, right? Yeah, you can expand this example into the multivariate set. So for the exercise, you can take help some other variables as well related to exercise. And for the health outcome, you can also measure some other variables, right? Consider the cholesterol level, blood pressure, your height, weight, right? So a lot of things. So ultimately, if you want to simultaneously analyze or simultaneously see the relationship among, it can be in the dependent, it can be in the independent. So correlation analysis might be very useful technique to solve this kind of problems. Canonical correlation analysis is used to identify and measure the association among two sets of variables. I told it already. Canonical correlation is appropriate in the same situation where multiple regression would be, but where there are multiple intercorrelated outcome variables. Yeah, the same problem maybe you can solve using the multivariate regression model or simple multiple regression analysis. But in reality, the problem is that we might face there are multiple intercorrelated outcome variables, right? That's the problem. So for this case or instance, there is no alternative of using canonical correlation analysis. So canonical correlation analysis determines a set of canonical variables, definitely orthogonal linear combinations of the variables within each set that best explain the variable both within and between sets. So you can consider independent variables or you can consider dependent variables. So I'm talking about the multivariate set of variables, right? So yeah, you can have the best explanation regarding the variability both within and between sets, right? Okay. So we can you hear me? Hello.
Yes, sir.
Okay.
Yes, sir.
So we can say the good examples for the canonical correlation analysis. A researcher has collected data on 3 psychological variables, right? Suppose a researcher has collected data on 3 psychological variables, 4 academic variables, right? So these 4 academic variables based on the standardized test score, right? Also, the researcher can incorporate another variable named gender and sample size like the 600 college students, right? The researcher is interested in how the set of psychological variables relates to the academic variables and gender, right? In particular, the researcher is interested in how many dimensions, or that means the how many canonical variables are necessary to understand the association between two sets of variables. So for this example, you can employ or you can apply the canonical correlation analysis. So there are some confusion, like because the data are very close as far as their characteristics, a lot of statistical modeling you have, and the objective of each modeling is also very close, right? So it's very difficult to distinguish each model from another model unless or until if you have a very good idea about the pattern of the data. So you have to have a very good knowledge, background knowledge about the data. So I'm talking about the cleaning of your data, right? And the assumption of the data is very important in statistical analysis. So you have to test the assumption all the time, and you have to see the pattern of the data, right? What is the pattern of the data? Anyway, some other techniques, but we are talking about the canonical correlation here. This is the main focus of our today's lecture, but there are some other techniques which might be also used to serve the same purpose you are like dealing with. But definitely there is a difference between the canonical correlation and the other techniques I'm gonna tell you right now. So what are those techniques? Separate OLS regressions. You could analyze this data using the separate OLS regression analysis for each variable in one set, right? And the OLS regression will not produce multivariate results and does not report information concerning dimensionality. So this is very important. So if you want to reduce the variable or if you want to see the dimension of the canonical variables, then I think the OLS regression will not be very useful. Rather, you can use the canonical correlation here. So multivariate multiple regression is also a reasonable option if you have no interest in dimensionality. The main focus of the canonical correlation is if your objective is to find the dimensionality of your variables, if you want to see the most important canonical variables, right? If you want to see the most correlated variables. So these are the objectives. If you have interest on these objectives particularly, then you can use canonical correlation. But if you are not really looking for the dimension or dimensionality of your variables, then I think you can just use the other techniques, as I told you right now, like the separate OLS regression, right? And if your objective is to cause an effect relationship, like for one unit change, if you want to see the change in other unit, in other variable, what changes occur. So for this objective specifically, you can use the regression, right? So, but the canonical correlation is very close, except the dimensionality of the variables, right? So dimensionality of the variables is very important if you want to apply canonical correlation analysis. So the example we just said, we are going to expand these examples for our today's lecture. So we are gonna perform some statistical analysis based on the R programming. And we want to show really how you can use the R programming, right? So we are going to expand on example one. On example one, what we just show only one example here. The example, the psychological variables, about investigating the association between psychological measures and academic achievement measures, right? So for the academic achievement measures, we can incorporate many variables. Your academic achievement can be like suppose I am considering one test, right? Like the GRE test. So the GRE test can be based on the reading. What is your reading capacity or capability? What is the writing capability of you? And what is your capability in math or the solving the math related problems also in the science? So these standardized tests are incorporated based on the four things: reading, writing, math solution, and science solution. So these are the some other variables you can incorporate. So mainly psychological measures and academic achievement scores, academic achievement measures, right? So we have a data file. This data file we are going to run using the R programming later on, and with 600 observations on 8 variables. So we have 8 variables. What are those variables? The psychological variables are locus of the control, your self concept and motivation, right? So these are the psychological variables. And the other academic variables are standardized test in reading. So this is one variable, writing is another variable, math solution is another variable, and finally science. So how many variables are here? There is 4. And additionally, there is another variable is the female. The sex or the gender of the variable is also of our interest. The variable is female. And this is 0, 1 indicator variable with 1 indicating a female student, right? So if it is 0, she's not female, definitely. He's a male, right? He's a male. So you have 8 variables now, and we are going to run the data using R, and the data consists of how many variables? 8 variables, right? So we will see this one later on. So we have to specify the psychological variables as the first set of variables and our academic variables plus gender as the second set, right? Because we are doing the correlation. So mind it, the concern is that you have to divide the data into several sets of variables because you have to find the correlation between 2 sets of observations. So what we can do, we can specify our psychological variables as the first set of variables and our academic variables plus gender as the second set of variables. For convenience, the variables in the first set are called U variables and the variables in the second set are called V variables. So let's go to the R program. So in our previous class, we already know how to read your data, right? So there are many ways you can read your data set. So today we will repeat the same thing. First, we have to read our data set. How we can read our data set? So this is the command. So this is the very easiest command ever in the R programming concept. So you just run this code and we can locate, the computer will locate your location for searching the data, right? So I am searching my data in my laptop. So the data is about, I already told you, is about the psychological variables and some other academic variables as well with the gender variables, right? Okay. Okay, so this is the data we already ran it, right? So if you want to see the data, okay, suppose I want to see the data, okay, so you have to run the variable, define variable. So this is the data. So better you can see, maybe see the view of the data set. So what is the view? So here is clearly here. So how many variables are here? Locus of control, self concept, motivation, right? These three mainly are the psychological variables. And reading capacity, writing capacity, or reading score, writing score, math score, science score, and the female or male, right? So, or the other gender maybe. So these are the categorical variables. So we have two set of observations. First three is the one set, and remaining 4 or 5 is the another set of observations. So we want to see the correlation, right? Focused on the canonical correlation among this set of observations. So because we are not doing the regression, right? So we don't need to be worried about the response variable because we are doing the correlation analysis. So just we'll see the correlation between set 1 and set 2 maybe. Let's take a look how we can do this one. So okay, so if you want to see the column, like how many columns have in your data set, you can just see your columns. You see the columns name. So you can take a look in the column, right? You see that this command will give you the column name, only how many columns in your data set. So you have control command, a column name, concept, right? Motivation, read, write, math, science, and sex, right? So these are the 8 title, right? Or the 8 topic of each column, right? So you can also see this one if you want to see really what is inside in the data set. So it's better to play with the data. I always tell you, try to play with your data. So you can just take a look of the descriptive statistics or the summary measure of your data set. So you can click on the summary measure and you will find the summary measurement, right? What you can see here, you can find the minimum value, first quartile, that means 25%, median value, mean value, third quartile, that means 75%, and maximum value of what? Of each variable. Summarize. So this is the summarized information of your data, or these are the summary measurement of your data. So for the control variable, we have the summary measure. For the concept, motivation, from read to science, all the variables you can see, you have the summarized informations are here. So it's better to play with the data. You can just take the summarized information from your data set. This is the basic step of statistical analysis, and you should go for it. So for our analysis, you need some packages, right? So you need to install some packages. So 4 packages specifically we need for this today's lecture: ggplot2, ggalilei, cca, ccp. So how, if you cannot install this one, just use one command, install.packages. Install.packages. Then you have to have this code. Then just write the name of the package, like the ggplot2, right? So for the graphics, this package is very useful. So after clicking, it will take some time to install the packages. After having the packages, you can just run in the library. So I already ran it, so I don't need to reinstall it again. So I just want to see you see I can run all the packages we need for the canonical correlation analysis, right? Okay, so you can also see some other things like for this command, you can take a look how many for the gender-wise distribution, right? How many for 0? How many zeros are here? That means the gender other than female, 273. How many females were there in my data set? 327, right? You can also play with the data. You can see these things, right? Just try to check what happens here. I just show you the code so you can run it, and you can just take a look what happens if you run this code, right? So these are some of the summarized things, nothing else. So we can just check like the ggps. Let's see what happens. Okay, so this is a plot. Okay, so what is this? Any idea? This is a correlation, nothing else. You see the variables are here. So here the control, this is for the control. So control versus control versus concept and motivation, right? So this is mainly the psychological variables, but we are looking for the whole data set variables, so we can take it later on. Anyway, so these are some of the basic things you can do it, right? So if you want to see the correlation within and between two sets of variables using the Mactor function from the CC package, you can use this command. Okay, Mactor function. So because you have to see the correlation within and between. I think you already know the concept within and between, right? So for the correlation, you have to see all possible correlation. So this is the advantage of correlation analysis. You can see the all possible combination of the relationship among the set of variables. So you can see within and between sets of observations, and you can use a canonical correlation. So try to run this command and you can see what happens here. So you see this is the correlation using a vector function. So control versus control, there is definitely the this is not the significant correlation. So for the other variables, you can see you can have the correlation here. So this is like a correlation matrix, right? For the 8 variables. So what we did, we see the correlation for each variable, like with one variable, with other variable, and we tried to find the correlation for all the combinations are here, right? So due to the length of the output, we will making comments in several places along way. So you can also run this command and you can just see what happens, right? So you want to see the display, the canonical correlation, you see the canonical correlation. So you find 3 canonical variables with the psychological variables, right? And you can also play with the data. You can select the array, some particular data set from 3 to 4, right? Here you can see the variables are here. You can also compute canonical loadings. So you can just try to know what is canonical loadings. You can also display what is the value of the canonical loading. So these are the value of the canonical loadings. You can also taste of the canonical dimension. And this is the important thing we were talking about, the canonical dimension. And for this one, you have to define some number of observations. So for the dimensionality, so you have to run this command, right? And you can also several statistic or function like the Wilks, lambda, Hotelling T square, Pillai, and Roy, right? So these are some of the function for the dimensionality, right? So you can run this one. You can also standardize psychological canonical coefficient using the diagonal matrix of psychological standard deviation. So you can run this command. Okay, so you can see that this, and finally the standardized canonical coefficient diagonal matrix of SR standard deviation is this one, right? So in this way, you can find the canonical correlation, right? So I am just show you the way how you can run this code, but it's up to you. It's up to your what should I say, like practice. So try to play with the data and try to have some result based on the canonical correlation. So this is all about today's lecture based on the canonical correlation analysis. So what we did in our class today, we tried to read our data set, right? So, and we try to play the data set also. We see the column names, we see the variable names, right? We also did the summarized statistics from our data set, but don't forget to download or don't forget to update your packages, because you need some particular packages for correlation analysis. What are those packages? ggplot2, GALLY, CCA, CCP, right? And you can also see the data summary. And finally, you can see the correlation, right? So you can play with, like, you can construct a lot of correlations from our data sets, right? So these are some of the commands and also some of the testing procedure for the dimensionality, right? So try to play with the canonical correlation analysis, okay? And I will give you the data set and here is the coding. So you can take a look and you can practice, okay? Practice will perfect you for the canonical correlation analyst, right? So I hope you all the very best. So this is all about the canonical correlation. So if you have any question, you can ask me. Otherwise, we have to finish our today's lecture, right? So the lecture was about canonical correlation analysis.